Yeah, we continue with the projectile. I think just to clarify one last thing before we move on to the problem solving exercise, which was drawn from the past paper. This is one physical science interesting graph. And now we said if you take the top of the cliff as the reference point and take downward as positive, which means that the slope in this case, because the stones start by going up, then we'll be starting with the positive slope in this case, and then come and then goes up, goes down. In this case, this will be when we take downward as positive. Now, because the slope of this one also it's your velocity. Yeah, sorry, we take upward as positive. The slope of this one is velocity, meaning that the first part of the velocity, which is when the stone is going up, the velocity is positive, and then the latter part of the motion, when the stone is going downward, is now the velocity is negative. That's why the slope is negative in this case. That is the first part. The second part, when we take downward as positive, then it means that now from the cliff, because the velocity was going up, therefore it will go in the negative direction. That's why the slope of the line will be negative up to the highest point, which is 5.1 meters above the cliff. Then from there on, because now it's heading downwards and we take downward as positive, the slope will be positive now. Can you see the positive slope? Yes, up until it reaches the height of 14.1 meters in that case. So in total, from here to here, from the top to this point, then it will be 19.2 meters above the ground. So the whole trip takes 3 seconds in air. I think it's clearer in this case when you take downward as positive and then when you take upward as positive. Thank you. Now let's come to one examination paper here, which now takes us to problem solving on vertical projectile motion. In this one, it was taken from 1 November paper, which says in a competition, participants must attempt to throw a ball vertically upwards past the point T, marked on a tall vertical pole. Point T is 3.7 meters above the ground, and point T may or may not be the highest point during the motion of the ball. One of the participants throws a ball vertically upwards at a velocity of 7.5 meters per second. You need to highlight that. That's the initial velocity. From the point that is 1.6 meters above the ground, that's the delta Y, as shown in the diagram below. Ignore the effects of air resistance, meaning that now the ball is a projectile. Fine. Now this is the diagram, and now they say in which direction is the net force acting on the ball while it moves towards point T. Remember we said once we ignore the effects of air resistance, the only force acting on the projectile will be the weight, which is gravity or gravitational force. Therefore, that is our net force in that case. Therefore, then the net force would be downwards according to this one. So that is 3.1. So it will be downwards because the only force acting on the projectile will be the weight. And give reason. Okay, I've already said the only force acting on the ball is gravitational force or gravitational force. Perfect. You get the 2 marks. Now the next question, they say to us 3.2, calculate the time taken by the ball to reach its highest point. Fine. Remember the golden strategy. just write VI, VF, A, delta T, delta Y, right? All the 5. First, the initial velocity is upwards. Remember, it always tell us which direction will be positive. Therefore, upward will be positive. A is downwards always. Therefore, it will become now negative 9.8. Fine. And then now let's go to the initial velocity is given according to the statement is 7.5 meters. And then we need to find the last one, because we know at the highest point where the ball will reach, its final velocity will be 0. Perfect. So now we can calculate the remaining 2. Anyway, they say calculate the delta y, meaning that there are 2 strategies of dealing with this one. We said is either you go for the formula with delta y, A, VF, VI, or others can say when we are counting delta y, nothing is said about the time, therefore we go for the formula without delta t, which is this one, VF squared equals to VI squared plus 2A delta y. VF squared will be 0 squared equals to 7.5 squared, then plus 2 into negative 9.8 multiplied by delta y. Therefore, your calculation here, if you deal with this question, oh sorry, well, we're calculating delta y, we're not calculating delta y, oh sorry for that one. Anyway, yeah, delta will be 2.87 meters, but anyway, we're not calculating this. They said, sorry for this one, we are calculating delta t. So calculating delta t, it will be now, we go for the formula without delta y. There's only one formula without delta y, which is the first one, VF equals to VI plus A delta t. Therefore, 0 equals to 7.5 plus negative 9.8 multiplied by delta t. Therefore, delta t, if you use your calculator, it should give you 0.77 seconds. Fine. That is worth 3 marks. Now determine by means of calculation whether the ball will pass point T or not. In this case now, as 3.3, then will the ball pass point T? We'll have to check, because now we are using maths here. If this is 1.6 meters, therefore we'll have to now subtract 1.6 from 3.7 and find this one. How much is it? If you've used that mathematics, you will find that now the distance in this case 1.6 and this then must be 2.1. So I mean that now for it to pass point T, it must travel 2.1 or more in that case. So we'll have to check that one. But according to this one, we've already calculated. Therefore, you just use now the very same given information and find the delta y. This is what we did. We just go for VF squared equals to VI plus 2A delta y. 0 squared 7.5 and then 2 multiplied by 9, negative 9.8. Delta y is 2.87. Remember we said the minimum for you to get to T, you must travel at least 2.1 or more meters or more. Therefore 2.87 is more than 2.1. Then we can now easily tell the examiner and say, no, fine, according to this calculation of hours, therefore the ball will be able to pass that point as indicated in that. So it will be now yes. The answer will be yes, the ball will pass point T. Now the next question, they say to us, draw a velocity time graph for the motion of the ball from the instant it is thrown upwards until it reaches its highest point. Indicate the following: the initial velocity and the final velocity and the time taken to reach the highest point. Now for us to calculate time taken to reach the highest point to left. We have already calculated 0.77. Yes, okay, fine. Then let's go. Velocity time graph. There are two options, remember, when you choose upward as positive, and let's say upward as positive, the velocity time graph will have the negative slope. Negative slope. Because we start from positive 7.5, and then we move past this one. This will be longer, this will be shorter. The time is 0.77 here. This is time in seconds for labeling. Velocity in meters per second. This is 0.0. So we have not calculated the final velocity in this case. But they say indicate the final velocity. So this will be just your VF, unless now we need to calculate it. That is the case. And then this is the velocity time graph when upward is positive. But when downward is positive, then the velocity time graph will be this. 0, velocity in meters per second, and time in seconds as well, time in seconds. Now we'll start from the negative value, because we say downward is positive, means that the initial part of the motion will have negative values, and then the final part will have positive values. This is 0.77. This will be negative 7.5. And then this will be the final velocity. And then the time taken to reach the highest point is the 0.77. Then that will be the case, I think, in this case. From until it reaches the highest point. Okay, then this will be just, I think you just need to draw these small parts. I think they need only from here to here. That's the case. So these are the two graphs, which one is when upward is positive. That's why it has got the negative slope, because when upward is positive, A is negative 9.8. So the slope of this graph represents the acceleration, which is negative here. That's why this one is when downward is positive, therefore A becomes positive 9.8. That's why it's having the positive slope. I think you get the difference when drawing this type of graphs, to say your choice will influence the slope of the graph in this case. Hopefully this is better and well explained, and with motion you will do better after these simple explanations. Go through the slides, go through the video, and then get to know the points. The most important thing in all the time is say write down all the 5, and then write what is mentioned here, and then you need to have 3 variables here. So have 3 physical quantities. Then those ones, they are the ones that will assist you. Minimum, for you to use any equation of motion, you need to have minimum 3 quantities. So once you have got 3, then you can go and apply it in the motion equations. Thanks a lot.